All right, so our unit is going to be density. We're going to be talking all about density for a few days. We're going to start it off real quick by just a little experiment, kind of an experiment, more of a visual. That's going to kind of help you guys understand it a little bit more, maybe. So, just a kind of question to ask. Obviously, we have all these liquids up here, but just an opening question. We have light corn syrup, milk, dish soap, water. It's just dyed red. Canola oil and nail polish remover, otherwise known as acetone. So, just a question. What do you guys think would happen if we were to put these all in one container? Would they mix up? Would they change color? Are we going to see them increase in size? Are they going to decrease in size? Just what do you guys think is going to happen? Okay, so just kind of take a couple minutes to kind of think about that for a bit. What I did though is I took a cylinder. And this is what you guys can do as well if you want to kind of try to mimic it. It's a little tough, but you can mimic it with like oil and water, just or maybe just a couple of these. But I took a cylinder and I put all these liquids in there. It took a little bit more touch. You can't necessarily just pour them because there's different factors that come into play there, but we don't need to talk about that right now. And just to save time, obviously, I'm not going to do it in front of you guys right now. I actually already did it, so I can just go ahead and show you what this looks like. So get your final guesses in, pause the video, do whatever you need to do. So 3, 2, 1. Okay, it's like a little color tower we got going on over here. And I know you guys don't have the greatest angle at it. I just got to make sure I can get everything in. But what we see is layering. Obviously, it's not one, it doesn't look like one liquid. It looks like a big mishmash of different things, and they're not really mixing at all, to be honest. Some parts are a little more than the others, and that's honestly more on me than it is the actual experiment itself. But yeah, so you just see definitive layering, and I have all of these different substances laid out in order of how they're poured. So the corn syrup is on the bottom, the syrup is on top of that, then you have the milk, then you have the dish soap, the water, the canola oil, and you can't really see it that well because I didn't use two different colors like I should have, but the acetone is on top of the canola oil. So really the one thing that obviously explains this, and it's what we're going to be talking about, is density. Density is the reason this happens. So when you think of density, I'm sure you guys have heard the word before. I don't know if you know exactly what it means, but basically what it is an object's mass divided by its volume. So it's how much space an object takes up. Let me move this back real quick. Or it's how much weight an object weighs in a specific space. So when you think of, something super dense, something super heavy for being so small, maybe like a piece of lead or a piece of metal, or you think of something super light for being so big and so voluminous, like a beach ball or something. That's basically referring to its density. So density, like I said, is simple as just mass divided by volume. This is the actual equation itself. And if you ever want to calculate density for something, you can do mass divided by volume. Now we will kind of delve into that a little bit more later because some things are harder than others to calculate density with, but we will hopefully cover as much as we can. So for mass, the units typically are going to be in grams, but obviously it can be in kilograms, megagrams, whatever you want it to be in. Milligrams, it doesn't matter. Usually grams though is what you're going to see. Now for volume, there are milliliters or centimeters cubed, and they are actually the same exact unit, but typically when we're referring to a liquid, we refer in milliliters, and when we're referring to a solid, we do centimeters cubed. So yeah, so that's kind of how you calculate it. So visually, density is going to look like this, obviously, like we said. So it forms these different layers. And when something is more dense than something else, if you have a liquid that is more dense than another liquid, it is going to want to it's going to want to sit lower than that because one liquid has a higher density, so there's less weight in that specific amount of volume. So say I had a super dense liquid and a really non-dense liquid. If I poured 100 milliliters of the super dense liquid, it's going to weigh way more than 100 milliliters of the less dense liquid, I should say. And this is kind of going back to the thing of what weighs more, a pound of metal or a pound of feathers? They weigh the same, but those feathers are going to take up way more volume than the metal will take up. And that's referring to density. So here, just to kind of explain these liquids, I could actually just bring up their densities and we could kind of walk through this. So we're starting at the bottom, and this is the densities of all the liquids here. So starting at the bottom, I'm going to move this over here a bit. Hopefully see it a little better maybe. Starting at the bottom, we have the corn syrup. So the corn syrup weighs per milliliter, it is 1.40 grams per milliliter. So it's pretty dense for a liquid. That is what is sitting at the bottom right there. So you can see a clean separation between that clear layer and that brown layer, and that would be the maple syrup and corn syrup layer. So I got these in order so you can kind of understand better. Maple syrup has a density of 1.37 grams per milliliter. So it is less dense than corn syrup. That is why it's setting above that. Okay, so if we were to take, exactly 100 milliliters of corn syrup and exactly 100 milliliters of maple syrup, the corn syrup is going to weigh more. Okay, and then you can see here we have I tried to keep some densities really close and some far away. So here's probably the biggest separation we have is the maple syrup to milk line. And I know you guys can't see it super well. I'm going to try to attach a picture or something to this video or link it to you guys somehow so you guys can see it, but because this is really a great angle for you to view. But hopefully you can see this clean line right here, okay? So that is the line obviously between the maple syrup and the milk. So milk has a density of 1.03 grams per milliliter, which is significantly less than maple syrup. So milk in the same volume as maple syrup will weigh less. And that is why there's such a clear separation, because milk is significantly less dense than maple syrup. Now moving on to dish soap, and I didn't really do a great job of this because I didn't pour it too, delicately, and that kind of gets into surface tension and stuff, but we don't need to talk about that yet. You can see a less clear line between milk and the dish soap. It's still clear, like you can tell this is milk and you can tell this is the dish soap, but it's getting a little foggy, a little cloudy, okay? That's because their densities are very, very similar. Dish soap's actually usually a little more dense, but the one I used specifically is 1.02 grams per milliliter, so it's a little less. And then moving on, we have water, which has a density of 1.00 grams per milliliter, okay? And it's less, but still, again, slightly less clear line. You can't really see it great in the light, but again, remember I did diamered so you could see it clear. Like I said, I'll hopefully attach a more well-lit, better angled picture so you guys can get a better view of it. But yes, and then another line that I think is probably our second most prominent, maybe besides the milk and maple syrup, is the water and canola oil line. So it is definite. If you were to get down, at face level with it, you could see, it'd be like a clean line. That's because canola oil's density is 0.91 grams per milliliter. So I'm sure you guys might have seen videos or something of someone pouring oil in water or vice versa, seeing a liquid mixture of oil and water. It's because you will usually see bubbles kind of forming of oil throughout the water. And eventually, if you let it set for a while, that oil will rise to the top and it will form two clean layers. And that is because canola oil's density is way less than water's, okay? And then the top layer, which like I said, I wish I would have dyed a color so you could see it better, is acetone, and it has a density of 0.79 grams per milliliter. And it is setting on the very top because it has the lowest density, okay? So that's basically what's forming these separations are the densities of each liquid. So kind of going back to this, if you were to, and we'll discuss this more, this is more kind of just an opening video to kind of help you guys visualize before we delve into calculations and stuff, but basically using this equation for each of these, we would find that as we move up, we will have a lower number for density, okay? Because that mass divided by volume ratio that we're gonna find for each liquid is gonna decrease. It's gonna slowly decrease, and that's what creates these layers, okay? So now, something that I actually haven't tried yet, hopefully it works well, but we'll kind of experiment together. I have 3 solid objects that kind of make you think. I have a water bottle cap, a tomato, and a screw. So we'll kind of see, because densities, everything has density, gas has density, solids have density, liquids have density, etc. And we can kind of, see what happens when we put both of these together. So I'm just going to drop this screw in. I'm going to move this closer so you guys can see it better maybe. Drop this screw in and we'll see what happens. Okay? So I don't know if you guys can see very well. I'm trying to raise this up a bit maybe. But you can see the screw went directly to the bottom. So kind of gathering what we just learned, we can come together and say, oh, that screw, which it's sunk pretty fast too, must have a higher density than everything in there. Maybe not the corn syrup, but I can tell you right now, it is sitting at the very, very bottom of that. And if there was a more dense liquid, it would want to sink down more. So we can kind of conclude from that that screw actually has the highest density of anything here. And usually solids do have higher densities. So most substances in their solid form will be more dense than the liquid form, other than water. Water is an exception. We'll talk about that more and kind of delve into that. And I can teach you guys some more fun facts about that. Okay, so now we have this cap, and there is a little bit of surface tension here, so we got to keep that in mind, but I'm going to kind of drop it in like this so we can see what happens. Okay, so it's resting on the top, and let's see if I can kind of poke it around a bit, see if I can. Okay, so you see that? So I made sure that it wasn't just resting there. So the cap actually is resting way higher, so we can conclude that it has a very low density compared to the rest of these liquids. It's very light. If I were to show you guys the cap, you would probably feel that it's very light. I will say it is sinking in the acetone layer, okay? So from that, we can conclude that that cap is, or maybe is a little more dense than acetone, but it's less dense than the rest of these liquids moving on down, okay? Now for the last thing, the cherry tomato. I don't know where this is gonna go. I just did it because I knew it was kind of in between that, so it'll be a little exciting to see, okay? I'm gonna kind of plop it in there and we'll see what happens. Alrighty, so you guys can't see it clearly, and I wish the liquids were a little more clear, but the cherry tomato is actually in the dish soap. I can kind of bring this up a bit, maybe bring it up to the lighting a bit. You can see a little bit more, but right in this area right here, the cherry tomato's there. And I will take a picture with these in there too, so I'll try to get a good view so you guys can see it. So we can conclude that the cherry tomato is more dense than these liquids for sure. Could be as dense or a little more dense than the Dawn dish soap, but it's still less dense than the milk, the maple syrup, and the light corn syrup. Okay, so again, I'm gonna kind of bring this calculation, these pages up on here for the last thing, and I'm gonna leave this like this. I'm hopefully gonna get a picture posted of this itself. I'm gonna leave this here. You can screenshot this, you can do whatever you need. It's gonna, hopefully it'll help you out a bit, but we are going to delve more into this equation and these units and everything, and we'll kind of figure out how to measure this stuff, okay? So hopefully that was interesting for you guys.